Hello there, Mr. Sutton here, bringing you the Algebra 2 7-2 Part 2 homework solutions on graphing rational functions. These are all in general linear form. For this problem, to graph this, since this is in general linear form, one way we can do this is by finding the asymptotes and then coming up with a few additional points. So that'll be my strategy on this one and all the other ones on this homework set of solutions here. So let's start with our vertical asymptote. To do that, we just have to set the denominator, x minus 3, equal to 0 and solve for x. We just need to zero out that denominator. So we have a vertical asymptote at x equals 3. For the horizontal asymptote, it's going to be the ratio of the lead coefficients. So we have a 1 over a 1 here because of these x's. And that gives us a horizontal asymptote of y equals 1. Now for additional points, I'm going to plug in an x value to the left and to the right of my vertical asymptote. So if I plug in x equals 2 to the original function, we've got 6 over negative 1, which is negative 6. And if I plug in something to the right of 3, like 4, so 4 plus 4 is 8 over 4 minus 3, which is 1. So that's going to be a total of 8. Putting all this on a graph, I've got my vertical asymptote at 3 right here, horizontal asymptote at 1, which is half a grid line the way I've done this. My first point is going to be 2 comma negative 6, which is down here. And then we have 4 comma 8 up here. Graph one branch in the lower left, my other branch is in the upper right. And the domain matching my vertical asymptote is going to be x not equal to 3. Range will be y not equal to this horizontal asymptote of 1. To start on this problem, let's first find the asymptotes for this graph. So for the vertical asymptotes, we need to see what makes the denominator 0. If we set x minus 4 equal to 0 and add 4, we see that we have a vertical asymptote at x equals 4. For the horizontal asymptote, we will take the ratio of the lead coefficients. So that would be 3 over 1. And that's just going to be y equals 3. And now for some additional points, we want to take something to the left and the right of my vertical asymptote of x equals 4. So let me plug 3 into all of this stuff, a little bit to the left of 4. So that's going to be, let's see here, 7 over negative 1, which is negative 7. And if I plug in something to the right of 4, like 5, into all this stuff here, we've got 15 minus 12, so that's 13 over positive 1, so 13. Graphing all this out, we have our vertical asymptote at x equals 4 over here. Horizontal asymptote at 3, which is about 3/4 of the way up this grid line. And then I have 3 comma negative 7, which is down here roughly. And then 5 comma 13, which is over here somewhere between 12 and 16. We have one branch going in our lower left and the other branch in the upper right. For the domain, we have an asymptote at x equals 4, so x cannot equal 4. And for the range, y cannot equal 3 because there's a horizontal asymptote there. For this problem, we're going to start by finding the asymptotes for this one. So we have a vertical asymptote wherever x plus 5, the denominator, equals 0. So that would be at x equals negative 5. For the horizontal asymptote, we take the ratio of the lead terms. So we have 1 over 1 for the x over x here. So that's just y equals 1 for that. And for my additional points, let me take something to the left and the right of negative 5, the vertical asymptote. So if I do f of negative 6, that's 1 to the left of this. That's going to be negative 7 over negative 1, which is positive 7. And now let me go 1 to the right of this negative 5, so plug in negative 4. That gives me negative 5 over 1, so negative 5. Graphing all this out, we have our x equals negative 5 vertical asymptote right here, and horizontal asymptote at y equals 1, which is about here. We have the additional point negative 6 comma 7, which is up here. And then we have negative 4 comma negative 5 down here. So there's one branch, and there's my other branch. And now for the domain, x cannot equal -5 because of this asymptote. And for the range, y cannot equal 1 because of our horizontal asymptote. In order to graph this equation, which is in that general kind of linear form, non-transformational form, I'm going to find my asymptotes first. So let me start with the vertical ones. That's going to happen wherever my denominator of 3x minus 1 equals 0. So if I add 1 and divide by 3, I've got x equals 1/3 for my vertical asymptote. Now for the horizontal asymptote, I just need the ratio of my lead coefficients here. So we just have 6/3, which gives me a horizontal asymptote of y equals 2 if I reduce that. For my additional points, let me take something a little bit to the left of 1/3. So I'm going to go for the easiest possible number to the left of 1/3. That's still pretty close, and that would be 0. If I plug 0 into all this stuff, I just have -1/-1, which is +1. And now something a little bit to the right of 1/3, 1 works pretty well. So if I plug 1 in, I've got, let's see here, 5/2. So that's going to be 2.5. Let me graph all this out. So I've got my vertical asymptote at 1/3, which is roughly here. Horizontal asymptote is at 2, y equals 2 right here. And then we have the point 0, 1, pretty easy to pick that one out. And then 1, 2.5, which is right about here. So we have one branch going through the lower left here, through this point. And the upper right, we've got our other branch. For the domain, we can't have this 1/3 x value, so we're going to have x not equal to 1/3 because of that asymptote. And then for the range, we don't want to include this 2, so we have y does not equal 2. To graph this function, let's start by finding the vertical and horizontal asymptotes. So for the vertical asymptote, I can set my denominator equal to 0, so -x plus 10 equals 0. If I just add x over to the other side, I end up with x equals 10 for my vertical asymptote. And then for the horizontal, I take the ratio of the lead coefficients, so that would be y equals -2/-1, which reduces to +2. For my additional points, let me plug in something to the right and the left of 10 here. So let me go 1 to the left and plug 9 into all that. So this is going to be -18 plus 3 is -15 over +1, so 15, or -15 rather. And then we have f of 11 I'm going to find next, 1 to the right of 10. So plugging 11 into my original, we've got -22 plus 3, which is -19, and that's going to be over -1, so +19 in that case. Graphing all this out, I'm going to make my x grid lines go by 2's so that I can fit this x equals 10 vertical asymptote. And I've got some big numbers for my y values, so I'm going to make those go by 4's to be able to fit all those. For my horizontal asymptote, I've got y equals 2 right here. Next, let me graph my points. So we've got 9, -15. So here's 9. Here is -15 right about there. And then we have 11, 19. Here's 11, and 19 is all the way up here near 20. So let me graph my lower left branch through that point, and graphing my upper right branch through the other point. Now for the domain, we have to leave out this vertical asymptote, so x cannot equal 10. For the range, we leave out our horizontal asymptote, so y does not equal 2.